Hello, and welcome to our Spectrophotometry Lab technique video. From this lab, we will learn the proper techniques to conduct a spectrophotometry experiment and analyze quantitative and qualitative data from the spectrophotometer. But what is spectrophotometry? Spectrophotometry is the method of determining how much light a chemical solution absorbs different wavelengths of light, which is often used with a spectrophotometer. In spectrophotometry, we scan across all wavelengths of light to determine what wavelength works best. Usually, it is the wavelength near the lambda max. The lambda max is the peak or wavelength of light where the maximum absorbance occurs for a chemical. Some chemicals absorb UV and IR wavelengths, so although through the naked eye they may appear colorless and clear, they can be measured by selecting a wavelength in the UV or IR range. For copper amine, the solution that we will be using in this experiment has a max lambda around 610 nanometers. Beer's-Lambert law relates the absorption value to the material it travels through. The equation is as follows, where A is the absorbance value, epsilon is the molar absorption coefficient, C is the molar concentration, and L is the optical path length. In this experiment, the cuvettes we are using have an optical path length of 1 centimeter. Qualitatively, the clearer and lighter a solution is, the lower the absorbance value will be from the spectrophotometer, at the set wavelength of 560 nanometers. Time to get started. First, fill your cuvettes with distilled water, stock solution, 3 serial dilutions, and the unknown to the marked indicator on the cuvette. In the spec room, clean and wipe down the cuvette containing the distilled water. This cuvette will serve as your blank for the experiment, which is used to calibrate the spectrophotometer. Open the spectrophotometer and place the blank into the machine, with the clear sides indicated by the arrow on the cuvette facing towards the beam. Close the spectrophotometer and zero the machine using the button on the left of the screen, making sure to get the absorbance value as close to 0 as possible. Remove the blank and close the lid of the spectrophotometer. Now the machine is primed and ready. Clean the clear sides of the cuvette containing the stock solution. Next, open and place the stock cuvette into the spectrophotometer with the clear side towards the beam. Using simple reads, select the read button. Record the absorbance value displayed in your lab notebook. Remove the stock cuvette from the spectrophotometer, remembering to close the lid once you have removed it. Repeat all the steps listed for the stock solution for the 3 serial dilutions you created and the unknown. From the data we collected, we can create an absorption versus concentration graph to determine the concentration of the unknown. Using the quantitative data, we can create a linear regression for our data to determine the concentration of the unknown. The linear regression created is, in essence, Beer-Lambert's law, where x is the concentration and the slope, 5.47, is the molar absorption coefficient times the optical path length. However, since our r-squared value is low, our regression equation does not fit the data we collected. Potential errors that may have occurred include having a cloudy stock solution, which may cause the stock solution's absorbance value to be larger than expected. The serial dilution concentrations may have also been too low, causing for poor readings from the spectrophotometer. Additionally, one of the cuvettes we used was scratched and damaged, which would also cause inaccurate absorbance readings. This is why you should always check your materials. As always, clean, dry, and return all glassware and cuvettes used in this lab once you have completely finished. Don't forget to wipe down your lab bench. Nobody wants to wipe it down for you. That's all for this lab. I hope you have learned the proper way to conduct a spectrophotometry experiment and how to analyze the data to determine unknown concentrations using a concentration versus absorbance graph. Thanks for watching!